Hello everyone, and thank you for joining this session. My name is Supratim Dutta, and I am an independent researcher with a background in large-scale enterprise transformations, quality engineering, and digital integration programs. Over the past several years, I have worked on complex telecom and enterprise modernization initiatives, including large-scale system integrations involving millions of customers and mission-critical platforms. Today, I will present my research titled Enterprise Integration Strategies for Large-Scale Digital Mergers. The goal of this session is to share a practical framework that organizations can use to reduce risk and improve the success rate of large-scale digital mergers. Large-scale mergers are not only business transactions, they are also technology transformations. When two organizations merge, they bring together decades of independently evolved systems, applications, and processes. The challenge is that these systems often have incompatible technologies, undocumented dependencies, inconsistent data definitions, and enormous operational risk. Millions of users and transactions continue to operate while the integration is taking place. Without a structured approach, digital mergers frequently experience delays, serve disruptions, and significant cost overruns. This research focuses on how organizations can create a repeatable integration framework that reduces complexity and enables a controlled transformation. In this presentation, I will cover five major areas. First, we will discuss architectural foundations and why decoupled designs and APIs are critical. Second, we will look at data migration and harmonization strategies because data quality often determines merger success. Third, we will examine testing and quality assurance at scale. Fourth, we will discuss operational continuity and how organizations can protect customers during migration. Finally, we will look at governance, infrastructure, and scalability. Together, these five areas will form an end-to-end integration framework. The first chapter focuses on architectural foundations. In large merger programs, architecture decisions made early have long-lasting consequences. If systems remain tightly coupled or depend on undocumented interfaces, every future change becomes more difficult and risky. Therefore, the objective is to create an architecture that is resilient, extensible, and capable of evolving over time. This requires decoupled design, microservices, API-based integration, and standard data contracts that clearly define how systems interact. There are four core principles behind successful integration architecture. The first is decoupled design, where systems communicate through well-defined contracts instead of direct dependencies. The second is modularity through microservices and bounded domains so that individual capabilities can evolve independently. The third principle is use of APIs and middleware to simplify communication and avoid complex point-to-point integrations. Finally, standardize and versionize data contracts prevent unexpected failures as systems evolve. Together, these principles significantly reduce integration risk. One of the most effective integration patterns for large-scale programs is the hub-and-spoke model. In traditional point-to-point architecture, the number of integration grows exponentially as systems increase. This quickly becomes difficult to manage. A centralized integration layer reduces complexity by providing a single location for routing, transformation, security, and monitoring. It also makes it easier to onboard legacy systems and progressively migrate domains without disrupting the entire ecosystem. The second chapter focuses on data migration and harmonization. In many mergers, technology challenges can be solved, but poor data quality create long-term operational issues. Source systems often define customers, products, and orders differently. Duplicate records, inconsistent business rules, and config identifiers create significant risk. Therefore, organizations need a common language for data and a disciplined approach for migration and validation. The core of data harmonization is canonical data model or CDM. The purpose of the CDM is to establish an enterprise-wide vocabulary that every system can understand. Instead of each application maintaining its own definition of customer or order, the data is transformed into a common structure before it is consumed downstream. This approach involves consistency, reduces transformation complexity, and creates a foundation for analytics and reporting across merged organizations. There are two common migration approaches. The first is incremental migration, where domains are moved gradually with validation and rollback opportunities at every stage. This approach reduces risk but takes longer. The second is the Big Bang migration, where everything moves during a defined cutover window. While it is faster, it requires extensive preparation and testing. Regardless of the strategy, organizations need to automate validation, audit trails, and structured exception handling to protect data quality and business continuity. The third chapter focuses on testing and quality assurance. In merger programs, testing is not simply a final phase before go live. It is a continuous capability that spans the entire delivery life cycle. Multiple systems, vendors, and teams are changing simultaneously, making defects more difficult and more expensive to resolve. Therefore, quality must be built into every stage of delivery through automation and rigorous governance. The testing pyramid provides a structured approach to quality. Unit tests validate individual services and are typically developer-owned. Integration tests verify APIs across system communication. System tests exercise complete business scenarios under realistic conditions. Finally, user acceptance testing ensures that the business is confident in the solution before deployment. Automation is essential because manual testing alone cannot keep pace with the scale and speed of merger programs. The fourth chapter addresses operational continuity. A merger program cannot stop the business from operating. Systems are changing while customers continue to use them, which means continuity planning becomes essential. Organizations must design strategies that allow them to migrate safely while maintaining service levels. This includes parallel runs, rollback capabilities, and comprehensive monitoring and observability. Parallel runs allow both legacy and target system to process live transactions simultaneously so that outputs can be compared. This significantly reduces cutover risk. Equally important is rollback planning. Every major deployment should have a tested and time-bound rollback procedure. Finally, observability provides real-time visibility into response times, error rates, and system throughput so that issues can be detected and resolved before customers are affected. The fifth chapter focuses on governance, infrastructure, and scalability. Technical excellence alone does not guarantee a successful integration. Organizations need clear decision-making structures, ownership models, and engineering standards. Strong governance reduces delays, improves accountability, and ensures that teams remain aligned throughout the program life cycle. Successful merger programs require cross-functional governance that spans both organizations. An integration program office provides coordination and decision-making authority. Architecture review boards guide technical decisions. Domain ownership ensures accountability, and change advisory processes manage risk. Effective governance should be viewed as an accelerator rather than an overhead because it reduces rework and improves delivery speed. Modern integration programs increasingly depend on cloud-native infrastructure. Containerization provides consistency across environments and reduces deployment issues. Orchestration platforms such as Kubernetes enable self-healing and automated scaling. Horizontal scalability helps absorb traffic spikes, particularly during migration periods when workloads can increase significantly. Predictive scaling further improves resilience by allocating the resources proactively based on historical patterns and real-time demand. This slide summarizes the entire integration framework. Architecture establishes the foundation, data harmonization ensures information consistency, Testing provides the solution and operational continuity protects the business during transformation. These elements are not independent activities, they form single delivery chain. Weaknesses any Weaknesses in any one areas increases risk across the entire program. The framework therefore promotes an integrated and disciplined approach to large-scale digital mergers. I would like to conclude with four key takeaways. First, decouple systems early and define clear contracts. Second, treat data as first-class risk and invest heavily in validation and governance. Third, automate testing, establish observability, and always prepare rollback procedures. Finally, recognize that governance is an enabler of speed and quality rather than a bureaucratic process. By combining these principles, organizations can significantly improve the success rate of large-scale digital integration programs. Thank you very much for your time and attention, and I hope this framework provides practical insights that can be applied in your own transformation initiatives.